Okay. So no, not multiplying like terms. Multiplying terms with variables, aka polynomials. I didn't really throw those phrases, those terms at you, polynomials, binomials, trinomials, because that just overwhelms people. All they got to know is that it's terms with variables. And today we're learning how to multiply terms with variables, aka polynomials. Alrighty, so let's go forth, my people. There are 4 people here today, which is kind of a shame, but whatever. Okay, very quick. What's 2x plus 3x? It's 5x, right? This is what we did yesterday. We first determined whether they were like terms, and then we just added the numbers and then threw the variable that they were both matching, and we just threw it on, right? Which is cool and all, but what if I were to have done this? What's 2x times 3x? 6x squared. So, now we're getting into multiplication here, people. This is the trick with multiplication. Before, in addition and subtraction, we did not care for the variable. Oh, actually, we did care about the variable. We first determined whether the variables were the same and if they were both to the same power, right? But when writing our final answer, we kind of didn't care for it. We just threw it on, right? In multiplication, you are now involving tricks with the variables. What are both of these variables to the power of? How do you think we got this squared here? We added the powers. So this is where the mix-up happens with a lot of students. They learn how to add and subtract variables. Then they come here into the multiplication world. Then we involve adding in multiplication. And that just trips people up and it confuses them. But as long as you know, hey, if I'm multiplying variables with terms with variables, any variable that's matching, as in the x and the x, we add its powers. Make sense? Make sense? Yep. So now comes this one right here. Another example. What if we had 3x squared y times 2x y z? First things first. First things first. Let's say I didn't have these parentheses and I had an addition sign there. Could you do that? Because they're not like terms, right? So, tell me, could we do this? Could we multiply these two terms? Why? They're not like terms. Guess what? Yes, it's multiplication. And in multiplication world, it does not matter if the terms are like or not. You could multiply anything with each other. And this is a good example, a good beginning example of that. So, how do we multiply this term with that term? Well, taking the step-by-step rule, all right? ask yourself, what is 3 times the other number on the other side, which is the 2? 6. Then ask yourself, what is the x squared times the other x in the other term, which is right there? What's x squared times x? X cubed, right? We're adding our exponents, right? Then you ask yourself, what is this y times the other y? Then you ask yourself, what is this z times the other z?
Z.
Exactly. If there's no other term, if there's no other like term or no other term, you just throw it down the way it is. Z.
I love this one.
Good.
This is it.
It's not easy. It's not easy.
You say that, my friend, but then comes the next thing. If we notice here, people, this is one term times one term, right?
Yeah.
AKA a monomial times a monomial. But what if we see this as a problem? Negative 2z squared times negative z minus 3yz. So, this is a monomial times a binomial. Actually, no, not even that. This is actually involving PEMDAS if you really, really, really want to think about it. What is PEMDAS? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, adding, and subtraction, right? A lot of people see this and they say, oh, I got to do whatever's inside the parentheses first. Cool, do it. Go inside. Is there anything you could do inside the parentheses? No, because these are not like terms. And when adding or subtracting, it has to be like terms. And these, my friend, are not like terms. So we move down our list. Are there any exponents? Huh? Sure. There's this one right here, right? Guess what? We don't know what z is. So we can't do that exponent. We can't do that square. So we move down the list. What's next? Multiplication and division, right? There is multiplication. It's this negative 2z squared times all of that. That's why this is a unique thing called the distribution. That's what it's called. The distributive property. There it is. Distribution. The distributive property. It's a unique thing because of everything that we just went through. We couldn't do what's inside the parentheses. We couldn't do any exponents. Is there any multiplication? Well, technically, yes. There is a little multiplication sign there, and you want to multiply all of this with all of that. But why is it called distribution? Distributing? Is because you do this. You distribute it outwards. You multiply it. But don't just do arrows. I always see students do arrows, and then they go finding the answers. Do it step by step. What is negative 2z squared times negative z? You do the answer first. Do you see why? What's negative 2 times negative 1? 2. What is z squared times z? Z cubed. Why? Because there's a little 1 there. And remember, we're adding our variables' exponents. Okay. Another Chipotle. So, That's one arrow done. Now distribute the next one. What is negative 2z squared times negative 3yz? Positive or negative?
Positive.
That's where my plus sign comes.
6z squared y. 6yz cubed. Is that right?
Yes. So step by step again. What's negative 2 times negative 3? 6. What's, okay, a lot of students would do this, and it's fine. It's fine. I should really do this as an example. A lot of students would do it step by step. They do negative 2 times negative 3 to create 6, right? Positive 6. Then they ask themselves, what's z squared times the other z, which is this one? Then they put z cubed. Then they say, what's this y times no y? Is just y, right? This is technically the right answer also, technically. But guess what? Math involves very, very, very little language arts. And do you know why we rearrange this into yz cubed? It's because of the alphabet.
A, B, C, D.
X, Y, Z.
But I don't think it doesn't matter.
It doesn't. They're both the same. It's true. But guess what? Your answers have to be alphabetical. In multiple choice options, you're going to see your answers alphabetical.
And how about
It's not wrong,
the power?
but it's wrong.
How about the power?
Oh, in this case,
Do we get a power?
huh? Do we what?
Power.
What about it?
Which one?
Like yesterday we put the big one at the front.
So you want this z cubed to be in front of the y? No. So that standard form matters about the whole thing in comparison to another one. But within the term, you must always have your stuff alphabetically. Does that make sense? Now, I ain't strict. I ain't too strict. If you were to put positive 6 z cubed y, I know you got it right. I ain't going to mark it wrong. But just keep note that those of you that are taking future classes, and for those of you taking GEDs, your multiple choice answers on your test, it's going to all be alphabetical. So did that make sense? But wait, there's more. There's a famous problem that looks like this. Right? Now, this looks eerily similar to what we did yesterday. Except, guess what? There's not an addition sign in the middle, nor a subtraction sign in the middle. That means multiplication, right? So you're not going to do the whole trick of erasing the parentheses or flipping the sign on the second one. That's only if you see an addition or a subtraction in the middle, right? Here is nothing in the middle. There's nothing you could do inside the parentheses. So guess what? We're doing straight up multiplication. But this is another famous one. Does anyone know the name of this type of problem? I heard it. Yes. FOIL. So FOIL. FOIL, believe it or not, stands for something, and this is why. This is why they created it. FOIL. First.
Outer, inner, and last.
Outer. inner, last. This is an acronym used so that you could memorize your arrows and how to multiply out precisely, right? For instance, you start with your firsts. Well, this is my first, this is my first. So you multiply those together. What's 2x squared times 3x squared? Right? So now you move on to your outer. You still stick with this first term, and you multiply it with the outer one. What's 2x squared times negative 4? Then you do your inners. What's my 9 times 3x squared? Those are the inner ones. Inners. Did I hear 7?
27.
Oh. Positive 27, right? Not negative? Positive, so that's why we put the plus there. 7x squared. Then I do my last. What's positive 9 times negative 4? Look at that. You just distributed. You just foiled. But, is there anything that you could see? Is there anything you spot that you can do extra? Yep. A little hint for you guys. Not all the times, but yes, majority of the times, your inner ones could be combined. Look at this. Negative 8x squared plus 27x squared. What does that become?
19.
Positive 19, right? X squared. This is what I'm telling you. People are going to get really confused. Here they have a habit of putting a 4. Why? Because they get in the habit of multiplying variables and adding the exponents, and they forget about multiplying or adding and subtracting. All you need to do is drop down the way it looks. So you just drop it down. Guess what? This is my answer. Did you say that's a lot?
That's a lot.
Oh yeah.
That's what I meant.
That's all. That's all the tricks to multiplying variables. You're going to drop that all the way off to Chipotle? So, any questions on this? Don't ask. So, quick recap. We have one term multiplying by another term. Take the step-by-step rule, right? Number times the number, the x times the x, the y times the y, the z times the other z, which there isn't none, right? Then you have your distribution, which is that one times both of these. Then you have your FOIL. That is what we're doing today. Are we ready?
Yeah.
Let's do this.